All right. Well, thank you very much for the opportunity to present here. I'm going to be talking. My name is Fernando Hoces. I work at BITS, and I'm going to be talking today about a project that we have about accelerating computational reproducibility in economics. This is something we've been working for about a year now, and we have some preliminary output to show you, and this is a great opportunity to get feedback and to still improve things. So I look forward to hear your comments. So if you don't know about BITS is the initiative within SIGA where we try to improve the credibility of science by advancing transparency, reproducibility, rigor, and ethics in research. And in particularly EightCare, the initiative that I'm talking today, this is the list of all the people who has worked in this initiative so far. The PI, it's Ted, and the co-PI, it's Lars Wilhover. Okay, so just as a brief motivation, I think that most of us are already aware of why computational reproducibility is important, but the one that I chose to highlight today is the idea of trying to prevent loss of knowledge, in the sense that every semester, graduate students around the world take some type of empirical or applied something, economics, labor, health, education, or something like that. And a typical assignment consists of reproducing the results of a paper and maybe doing some robustness checks around that paper. And in this exercise, students go through something like this. So first, they choose a paper, or they are assigned a paper, and in that instance, they already generate some knowledge in the sense that they identify if there are materials to reproduce the paper. Then they assess the degree of reproducibility of part of the paper, so that's also new knowledge. Then they might improve the reproduction materials or reproduction package in small or large ways, but each of these is a new piece of knowledge. And then they might test the result, to test the robustness of results, and particularly they find that the results are robust to new specifications that they are not mentioned in the paper, but the results withhold, they're going to have little incentives to report it somewhere else. So in each of these stages, there's going to be valuable new knowledge, but it's usually non-disseminated. At best, it's going to be in an end of semester report, a presentation, or something like that. The problem is going to be when trying to aggregate these things across courses and across universities is that the language is non-standard. We still have not agreed upon how to call this thing where we take the same data, the same code, and try to get the same result. In some places you call it reproduction, some places you call it replication. Here we want to try to focus as much as possible on calling it computational reproduction. And there are some current attempts to record this information, but they get much closer to wanting to report a full paper. So they ask of the reproducer to write a full paper around this exercise. And this knowledge that was generated might not be best suited to be put on a paper. So as a result, you have a lot of missed knowledge each semester. There's a lot of reinventing the wheel, and there's a lost opportunity in terms of building on top of previous knowledge, and also a lost opportunity in terms of aggregating the knowledge that was generating in a systematic way. And that's basically the gap that we're trying to fill in with the EightCare project, which is basically composed of two big items: the EightCare guidelines that I will be describing here today, and the EightCare platform. The EightCare guidelines are completed and published, and I will show them today. The EightCare platform is still in a beta or in development format. I will be able to show you some part of the platform today. So the context for EightCare is that in the way we understand EightCare is that in 2006, the American Economic Association creates its first data policy, and only then it started asking for papers to for authors to submit in the AEA journals, to submit some type of data. Then the requirements to submit some data, waivers are available, but this basically it's an important step in the sense that it generates it pushes authors to publish some data, but it leaves a large amount of space for people to either apply for waivers or submit a partial amount of data and code. In last year, in 2019, there was a major update to the AEA policy led by the data editor Lance B. Hoover. And the idea, the requirements now are that authors must post all data and code. Publication is conditional on verifying the reproducibility of the results. And if the data is confidential, authors are still required to submit extensive documentation on how to access the confidential data. In addition, there's a new requirement that asks authors to post all the cleaning code, something that was not asked before, even if the data it's not public. If you want to see more about this, I put the link there for the AEA data editor website. The way we use this basically to manage our expectations, in the sense that we should expect high levels of computational reproducibility after 2019, at least in the AEA journals, but we should not demand 100% of computational reproducibility before. This was not the norm. We should not demand it, but that we can still identify gaps and try to improve some papers where that's possible. So one very important decision that we took early in the project was to say we want to move away from this binary judgment. I think that this is where the conversations get very adversarial, and we want to have constructive dialogues around reproducibility. And by this, we're making very explicit that early career researchers have incentives to emphasize unsuccessful reproductions. This is something that Gerter, Galliani, and Romero called the Overton bias, but also original authors have a more senior position and can use it to deter in-depth reproductions, and we need to be aware of that. And on top of that, you have the media that puts a high premium in eye-catching results, like this doesn't reproduce, this does reproduce, or something like that. So we do not want to say paper X is reproducible or irreproducible. That's we're trying to stay away from that. What we're trying to say is something like result Y in paper X has a high or low level of reproducibility according to several reproduction attempts. Moreover, improvements have been made to the original reproduction package, increasing its reproducibility to a higher level. And here we want to emphasize this idea of degrees. We want to emphasize that we want to pull several reproduction attempts, and we want to emphasize improvements. And how do we do that? We try to think of the paper as something that contains several units. Each unit is going to be a scientific claim. So we're trying to break up a paper into the scientific claims that are described in a paper. By scientific claims, you can think of as the major hypothesis studied in the paper. And each scientific claim is going to be supported by evidence in display items. A display item is going to be a table, a figure, or an inline result, and we're going to focus the reproducers to focus around, first of all, the claim. The claim is going to be the center of the reproduction exercise, not the paper. And for each claim, we're going to ask them to specify what are the display items that they're going to focus on, and within a display item, what are the specifications that they think are the preferred specifications for the result. And we're going to walk reproducers through stages. The first stage, we're going to ask them to scope the result, to scope the paper. Here, the challenge is that many reproducers might select several papers or browse papers and identify that there's no reproduction package and just skip them easily. We want to capture that information. So we're going to ask reproducers to check if there is a reproduction package, or by reproduction package is any materials to reproduce a paper. And if there is a reproduction package, we will guide them in continuing the exercise. If there's no reproduction package, we will ask them to leave a brief record and then switch to another paper. And the record would be something like this for other reproducers to see later on. Basically, the name of the paper, whether or not there's a reproduction package, if there's a reproduction package, how many more reproduction packages are they generated by the reproducers? If there's no reproduction package, were the authors contacted? And if they were contacted, we have categories of the type of responses. And we also have a way of recording whether or not authors do not want to be asked about the same issue again. So on the one side, probably original authors will be contacted more because of EightCare, because we are providing guidance on how to do it. On the other side, original authors might be contacted a little less because we are emphasizing that authors should not be asked twice for the same thing. We want to record those interactions such that the response is recorded, and then there's no need to follow up on the same thing twice. That's scoping. I don't know if there's any questions so far. Oh, I'll move to assessment. So assessment is close to the core of the exercise, where basically we first ask reproducers to find all the elements behind a specific display items. And by elements, I mean all the elements that are used in a reproduction package. And then once they have a detailed understanding of all the pieces behind a display item, then we ask them to score the reproducibility of a specific display item. So first, we ask them to draw, to identify what are the data sources as described in a narrative form in the paper, and try to connect them with specific raw data files in the reproduction materials. Then we ask them to list the analytic datasets, meaning the datasets that are used in the final analysis to produce the different results, and to inspect the code files and record what comes into a code file and what goes out, what comes out from a code file. With all these elements, then we can feed them into the EightCare diagram builder that it was developed by Joel Ferguson, that I think he's here, and the idea is that you feed this information into the EightCare diagram builder, and you get something like this. That at the end you have this is a simple visualization that at the end shows you the display item that you are trying to reproduce, and tries to deconstruct all the different pieces all the way down to the raw data. This is for a complete reproduction tree, but the builder also will generate incomplete reproduction trees, and the guidelines will guide you on how to try to reconstruct the tree as a reproducer. With all the information, then the reproducer is ready to perform an assessment of a specific display item. And the assessment here, we came out with these levels, again, moving away from the binary assessments and moving to levels of computational reproducibility that they basically what we propose is to increase from level 1 being not reproducible at all, and level 10 being completely reproducible from raw data, and we progress in those levels from asking first to have some code for analysis, some code for data, and then once you have some code for analysis and for data, verify that it's computationally reproducible from the analysis data, or CRA, and then progress to cleaning code and raw data and ask if it's computationally reproducible from raw data. And that's how we, and the for each category, reproducers can report if the information is partially there or it's complete, and that's how we would guide them to assign a score for a given display item. Yes, so what happens if the information if there's some data that's confidential or proprietary? We modify this scale to account for that, and when there's proprietary or confidential data, we will not ask reproducers to obtain either analysis or raw data, but we will ask them to obtain instructions or verify that they are instructions to obtain that data and assess those instructions. So that leads to changing some of the levels. The ones that I'm highlighting here change in the sense that now the reproducer has to check whether or not there are instructions to the data and to the data in analysis and in raw form, and to achieve the levels of reproducibility corresponding to reproducibility from analysis data level 5 or from raw data level 10. We ask authors, again, this is following the new EightCare, the new AEA recommendations. We ask authors to provide proof that a third party was able to reproduce the results, starting either from the analysis data or from the raw data. Any questions regarding assessment?
The one thing I didn't see in your assessment chart was, one of the things you mentioned earlier on is thinking about the robustness of results. Yes. So this looks very much like what the AER makes you do now, right? Where somebody checks your do file to see if exactly they can reproduce the tables. Yes. But that's different than the other sort of goal you had stated.
Yes, yeah, exactly. So we're moving through a stage, and once the way we think about it is that once we're done improving the reproducibility of a current reproduction package, then we play with we assess the robustness.
Okay. And is there a process for authors to sort of object or try to if they feel like they've been unfairly categorized by a student, there's their process in place?
There's what we have is guidance in terms of how to carry out the communications. So I'll show in a little bit what types of template emails we are providing for having these type of conversations. And one thing that I also have to emphasize is that it is the authors can object to specific reproductions, but also it's important to take into account that we're going to try to, when we report the results of this, we're not going to report a reproduction. We're going to try to report as soon as we have 3 or 4 or 5 reproductions. That's when we're going to say something about a display item in a paper.
I see. And then
go ahead, Supreet. I was just going to build.
I was going to say, would authors be notified? So say that the first reproduction comes in and it doesn't quite match up. Would you wait for all 3 and then it kind of becomes public, or would you notify the author after the first one that, hey, there might be this issue?
We have not think of a procedure for that, but that you wanted to jump in?
I was just going to say, I think Supreet's raising a really good point. My understanding now, Supreet, is anybody could contribute to the platform, including the original author. So the original author could themselves go and assess robustness or put, analyze results. So they could sort of be in dialogue with a reproducer on the platform, because anybody can kind of contribute. So I think that's one way that they can sort of get their perspective out there, is on the platform itself. They can have their preferred analysis or the discussion of code. In terms of contacting the author, I think it's a good point that as soon as this process starts, there can be communication with the original author. I think what Fernando was noting before is there would be some process of embargoing, either until there's a certain number of reproductions or for a certain amount of time until it's made, public to the world. And I think that embargo period would be most effective if there was a dialogue between the original author and the reproducers, where they can sort things out, put their, maybe either reach a consensus or put their own perspective on the platform before it's made public. So These are some of the details we're like sorting out now in terms of figuring out how best to structure it. So your thoughts or reactions about the right way to do it would be like incredibly valuable, since we're hoping to push this out in the coming months.
That makes sense to me. That sounds very sensible.
Okay, so in terms of the next stage of improvements, I think I'm going to go pretty quickly over improvements to have time to go over robustness on the platform. But basically, the ideas are we guide reproducers on different types of improvements at the paper level and at the display item level, how to make a specific display item more reproducible. And one thing that this is, I think, was a suggestion, but Maddie Dujon, I hope she's here, this idea that reproducers also learn what could have they reproduced in the future, but they might not have time. We're gonna ask them to leave a trail of instructions for future reproducers on how to improve and where to improve things. And going to robustness checks, here, the idea is that we're gonna ask reproducers to contribute in either two areas. One is to increase the number of possible robustness checks, and the other one is to justify the appropriateness of a specific test. And here, the way we think about this is that a robustness check is going to be any possible change in a computational choice, both in data analysis and data cleaning. And this leads to having the universe of robustness checks being pretty large, possibly infinite. And we wanna do two things. We wanna increase the size of the feasible set of things that are that is feasible to reproduce with the reproduction package, and we want also to justify that some of those elements are in the reasonable set. And the reasonable set, here we're following Simon's work authors, that the definition of reasonable is basically when a test, it's a sensible test of the research question, when it's expected to be statistically valid, and when it's non-redundant with other tests that are being proposed already. And basically here we're thinking of two types of contributors to this stage. One, it could be a reproducer that does not have that much expertise with the specific subject or methods, but she or he can pinpoint where are the different analytical choices. And then another type of reproducer that's going to spend a lot of time thinking very hard about one specific robustness check and justifying it and discussing its reasonableness. And one thing is that the extent of robustness is directly linked to the level of reproducibility. If it's not reproducible, we cannot test the robustness of anything. If it goes 2 through 4, we cannot get to the paper yet. If it's 5 through 9, you can reproduce some of the things in the paper. If you get to level 10, you can check the robustness to everything in the paper and more. Getting to that's the exercise over the 4 stages. Getting to the aspect of having a constructive exchange between authors and reproducers, we in the guidelines we built an entire chapter that basically provides scenarios and how to approach authors under those scenarios. We're now also working on scenarios for authors and how to approach reproducers, and this is a very helpful work that has been led by Alex Bogdanowski at BITS. Here, just one quick example. For example, here's one scenario of following up on additional materials. Here, the reproducer, it's approaching the original authors and saying, dear Dr. X, thank you for sharing the materials. They have been immensely helpful for my work. Unfortunately, I ran into a few issues. And then we tell them, please describe the issues in detail. And in the guidelines, we show them what's an incomplete description. And here, I just want to show you a complete description where we're really pushing reproducers to be as thorough as possible. The idea is to say, OK, I'm specifically attempting to reproduce this display item. When I build my reproduction tree, these elements are missing. These elements are unknown. Could you please help me find these files or let me know where I might be able to find them? And if you do this, it will help ensure that nobody will ask you twice for the same thing. So that's what we're thinking. Another element that I wanted to highlight is that this, as an instructor, if you have your students use the platform, it also generates some tools that will make you easier for you to grade these tools. So we're building some automated reports that come out of the reproductions. Here's an example that it will have the name of the paper to reproduce, the DOI, how many entries have been conducted yet, some statistics on the reproduction, comparing. So these are the number of claims that all the EightCare entries have declared that this paper has. There's some agreement, so there's no all identify 4 claims. There's some differences in that some reproducers try to reproduce 1 claim, another might have tried to reproduce 3 claims or something like that. Some characteristics, and we have these tables that are automatically generated that put the information that the student fill in, so identifying what's the claim, and right below what is the preferred specification and where that preferred specification is located in the original paper. So you can later on go to have them side by side, and you have it here, and you can look in the paper, and you look for table 2, and this is table 3, table 2, and you will find the same estimate, 1.69, 1.69, and it kind of like as an instructor, you're able to see like, this student, it's getting what I'm asking for. They might be a little bit lost and might require a little bit more guidance. This is just some suggestions of how to guide students depending on the level of effort that they will be doing as an assignment. It could be a 2-week assignment, a 1-month assignment. They could be working on through the entire semester. And these are some suggestions of how to distribute their time and their efforts on each stage. And the last thing I wanted to show you is the platform that we have in what we have so far. And there's the link. You can go to it. Any information that you record right now, it's not going to be saved permanently because, again, we're developing things. But the idea is that you can start with your own reproductions here, and you will go through these stages. So you can record a new candidate paper and go through the basic information. Is there a reproduction package available? If there is, you can move right away to declare this paper and move forward. If there's not, you record the specific information that I described before, and then some questions regarding how much do you know about this paper, so how many display items this paper has, and things like that. That's the at least the scoping stage it's fully ready for you to review. The assessment stages will be ready soon. We're hoping by the end of by the early November to have all the stages ready for you to test them. And the last thing I wanted to point you out is also the guidelines. The guidelines are ready and they are public for anybody to see them, but also to contribute. So here's the URL. Here's the guidelines, and you can see each section. You can contribute to. You can review them and contribute if you see that there's some area for improvement. So
I'm sorry if I could interrupt for a second. One thing that a complaint that I've heard from a bunch of people that have had famous papers replicated is usually about this checking robustness thing. And it comes down to the fact that our hypothesis testing framework is really not well suited to interpret the fact that one heterogeneity test would deliver a statistically significant result and a different one did not. Like that's not a piece of evidence that is particularly interpretable in a standard hypothesis testing framework. And so it makes sense that people would be annoyed when they get a report back saying, well, I tried this other equally sensible thing and it didn't work. I wonder if a way to improve author responses is to not call that robustness at all, but instead to call it something like deeper investigations into the data or other evidence just identified in this data, and sort of treat it rather than a means of like making it feel like a gotcha means of finding some mistake that someone did or a result that's definitely wrong. But instead of saying how much can we learn from this data set that that might not have made the original paper, and sort of so you're learning something different. You're learning okay, there isn't significant heterogeneity on this other dimension that sounds an awful lot like the one that was emphasized in the paper, and not that the one that was emphasized in the paper was wrong per se.
That makes a lot of things, a lot of sense, and thanks for the suggestion. My only question would be that you still might want to leave space for reproducers to test some type of robustness. Just for example, if you want to make sure that there was not selection on specific variables to report or things like that, and that would go into the category of robustness, or you were thinking even that you will put it in deeper investigation?
I think if there's a formal statistical test, like I think anything in robustness, to call it robustness, I would want it to be interpretable via a formal statistical test.
Okay.
And so if it's not interpretable by a formal statistical test, I wouldn't say it's saying something about robustness. I would say it's some other feature of the data that you're highlighting.
Okay, that makes sense. We'll take that into consideration.
Can I add some thoughts? When I got contacted to do this, I remember spending a lot of time getting the other person's programs to work. They didn't have the same Stata version. They didn't have the same updates. I mean, we had to really do forensics just to get it to run on their computer. Programs had been changed and modified. And so I'm wondering whether this effort would be valuable also if it provides guidelines to authors about what are easy ways, to facilitate this type of analysis ex post. When we start a project, we have quite a lot of leeway. Once we're done, it's really hard. We have some sense over time of making things check, right, more. But I think you guys are going to acquire a lot of knowledge about what software is more reliable over time, that breaks up less, and provide that type of advice. I think would help a lot. Like to give you an example, should I use QGIS or ArcGIS nowadays? One of them is open source. That one of those might be better for reproducibility down the line. But it would be great if we had guidelines, I think, from this type of work. I would suggest, given that most papers don't have much impact, I think you guys should have, I think it would be great if you kind of got some metrics about how influential a paper is becoming, maybe a year after publication or during the working papers phase, and then try to get those to be reproduced more, to do this analysis on the ones that we're deciding more things based on those papers. Because it seems like a lot of work. I mean, I'm worried that you're going to set up this platform and not enough people are going to want to put in the work. So I would say the most valuable thing would be let's apply those to the more influential papers. Those are my two reactions. Thanks.
Thank you. So we have not think of the list of papers to reproduce as a wish list of papers, but that's something we can definitely incorporate. And I think from us if over time we have more, we see a recurrency of certain issues coming up in terms of limitations to reproducibility, we can report that as recommendations for how to make this more straightforward. So yeah, that's something we can look into it and work on. And I know it's 5 minutes past, but if you wanna contribute, give us more feedbacks or participate in any shape or form to this, please contact us, particularly me or Alex Bogdanovsky at BITS.